This animation graphically demonstrates track features present in the accident. On January 29th, a welding crew arrived to replace a segment of the rail. The blue rail represents the rail that was removed. The rail temperature was 60 degrees Fahrenheit at the time of the replacement. Let's look at the rail contraction in detail. As the arrow indicates, when the welder cut the rail, it rapidly contracted because the steel was cold. Therefore, the gap between the rail ends became larger. The red rail represents the rail that was inserted. The replacement rail had to be 2.5 inches longer than the rail that was taken out. About 2 months after the rail segment was replaced, with warmer spring weather, the rail temperature had increased significantly, producing expansion of the continuously welded rail. On the day of the accident, the rail temperature had increased to about 114 degrees Fahrenheit due to the warmer temperatures and radiant heating of the rail by the sun. The excess rail from the winter repair and the lack of adequate rail restraints allowed the rail to expand above the shoulder of the tie plates at this location. The rail began to move upward, then outward, creating a bow in the rail that allowed the train wheels to drop in between the rails. This arrow shows the direction of the accident train. Please note the wide gauge condition ahead of the arrow. The train derailed as it moved past this bowed portion in the right rail.